Today we're talking about inverse trig functions when the values are not on the unit circle. So we have a little sketch of our 6 inverse trig functions, just as a reminder what they look like. Okay, if it's not on the unit circle, what are we going to do? This composition asks us for the cosine of the angle whose sine is 4/5. So remember, that's really just asking us for the cosine of some angle theta that we don't know yet. Well, the problem is a sine of 4/5 is not on the unit circle. So what do we do if it's not on the unit circle? It's not super scary. We're just going to draw a triangle. Draw a triangle. Specifically, we're going to draw a right triangle in the correct quadrant. So what quadrant should it be in? If the sine is positive, we know sine inverse only gives us 2 choices. That's either in first or negative first quadrant. And so since it's positive, it's going to be in first quadrant where everything's positive. So we're going to draw a triangle in quadrant 1. And we know sine is y/r. That means my y value is 4. And my r value is 5. And we want to find the cosine of this angle theta. We want to find the cosine of this angle whose sine is 4/5. Notice that we never actually have to find the angle. We can just draw the triangle for that angle, and we can use the 2 sides of a right triangle to solve for the third side so that we can get any of the 6 trig functions they ask for. So let's do that. This one's a Pythagorean triple, so I don't even have to do any work to solve for it. I know that my remaining side x will be a 3. This is a 3, 4, 5 triangle. So if they would like the cosine of the angle whose sine is 4/5, the cosine of that angle is just x/r. And so that would just be 3/5. Okay, you can write it all together as one statement if you would like. The cosine of the angle whose sine, and remember that's how we can read sine inverse, as the angle whose sine is 4/5 is 3/5. Okay, and thinking about what you're saying, the cosine of the angle whose sine is 4/5, so the cosine of that angle is 3/5. And looking at your picture, you can see that makes sense. Okay. So our thought process here is it on the unit circle? If it is, then we're thinking about what quadrants are we in? Where do we see that value on the unit circle? And then that angle is our answer. Okay, if it's not on the unit circle, we're going to draw a triangle. Notice that this time we won't actually find the angle. Instead, we're going to find the other trig functions in terms of SOHCAHTOA, x, y, and r. And this is our answer. Okay, so let's try that again. We'd like sine of the angle whose tangent is -8/3. Okay, so we want the sine of this angle. We want the sine of the angle whose tangent is -8/3. The problem is there's not an angle on the unit circle that has a tangent of -8/3. So what are we going to do? We're going to draw a triangle. Now, what quadrant should we draw that triangle in? We're doing tan inverse. It's the angle whose tangent is -8/3. Well, tan inverse only gives us 2 choices. It's either quadrant 1 or -1. Remember, that's really fourth quadrant, but I call it quadrant -1 to remind us that we're going backwards into it when we need it. And if that tangent is negative, we're going to be there in fourth quadrant or negative first quadrant, however you want to say it. Okay. Now remember, tangent is y/x. Tangent is y/x. So this means my y value is 8 and my x value is 3. Now, one of those two has to be negative because this is a -8/3. Well, in quadrant 2, which one is negative, the x or the y coordinate? You can see it's the y coordinate because we're coming down into quadrant 4. I think I may have misspoken on my quadrant there a second ago. All right, so if we know 2 sides of a right triangle, we can find the third side with Pythagorean theorem. This one is not a triple. We got to do a little work here. We're looking for our r value, our radius, okay? So we've got 3 squared plus -8 squared equals r squared. So that's just 9 plus 64 equals r squared. So that's 73. And if we take the square root of both sides, We pick up the plus or minus option. Remember that for the radius is always positive, so we'll throw out the negative option. So my radius is square root of 73. And now we can find any of the 6 trig functions we want. Notice that we never actually found the angle itself. Okay, we never actually found the angle theta. But since we have all 3 sides of its triangle, we can find any of the trig functions we want. They want sine. They want sine of the angle whose tangent is negative 8 over 3. Well, sine is y over r. So our y value is negative 8. Our r value is root 73. And are we finished? It feels like we should be, but we've got one more step. We've got to rationalize that denominator. So I'm going to multiply the denominator by root 73, multiply the numerator by root 73, and that equals negative 8 root 73 over 73. Okay, let's try that again. So we want the tangent of the angle whose secant is 13 over 5. We want the tangent of the angle whose secant is 13 over 5. Okay, so the angle whose secant is 13 over 5, that's just some angle. I can think of it as theta. That's some angle theta. And we never actually have to find the angle theta as long as we can find its tangent. So let's think about that. The angle whose secant is 13 over 5. 13 over 5 are not values from the unit circle, so I'm going to draw a triangle. Secant is the reciprocal of cosine, so for cosine and for secant, we're either in quadrants 1 or quadrants 2. This one's positive, so we're going to be in quadrant 1. Okay, and we remember that secant is r over x, so my r value is 13, and my x value is 5. Now this one is also a Pythagorean triple. Did you spot it? Okay. It's a 5, 12, 13 triangle, so my y value is 12. Now, we never actually found our angle theta. We never actually found theta, but we've got all 3 sides of its triangle, so we can find any of the 6 trig functions they want. They want tangent of the angle whose secant is 13 over 5. Well, that's this angle. What's the tangent of this angle? Tangent is y over x. So for this triangle, for this angle, that would be 12 over 5. Final answer. Tangent of the angle whose secant is 13 over 5 is 12 over 5. Okay, now let's try our last one. We'd like to find the cosecant of the angle whose cosine is 0.25. We'd like to find cosecant of the angle whose cosine is 0.25. I'd like to think of that as a fraction. It helps me think of the sides of the triangle, so we want to rewrite that as a fraction. So that's just going to be the cosecant of the angle whose cosine is 1/4. 0.25 is just 1/4. Okay, so we want to be able to rewrite that. Now, 1/4 is still not values on the unit circle, so I'm going to draw a triangle. Cosine inverse is positive, so we're in quadrant 1 where everything's positive. So cosine we know is x over r. So my x value is 1, and my r value is 4. If we know 2 sides of a right triangle, we can find the third side with Pythagorean theorem. So 1 squared plus y squared equals 4 squared. So that's just going to be 1 plus y squared equals 16. Subtract 1 from both sides, we get y squared equals 15. Undo a square with square root. When we take the square root of both sides, we pick up the plus or minus option. So that's going to give me y equals, in quadrant 1, everything's positive, so we're going to throw out the negative option. That's just going to be the positive square root of 15. Now that doesn't simplify because the square root of 15 is just the square root of 3 times 5, so there's no pairs, so nothing comes out, so it just stays the square root of 15. So y equals the square root of 15. Okay, so we want the cosecant of the angle whose cosine is 0.25. That's angle we're thinking of as theta. We don't have to find theta to find its cosecant. Cosecant is just r over y. So my r value here is 4. My y value is root 15. When I rationalize it, multiplying by whatever's under the radical in the denominator, what I do to the denominator, I have to do to the numerator. And that's going to give me 4 root 15 over 15, final answer. And that's it. Not too bad. Just drawing triangles when it's not on the unit circle.